So, in the last class we talk about capacitor, finding capacitance of capacitors like parallel plate capacitor, spherical, cylindrical, and then we have seen series combination and parallel combination formula, right. So, today we will take up circuits which involves capacitor. So, before getting into how to solve the circuit, there are basically two laws associated with it, right. Those are Kirchhoff's law. So, in this session we will see Kirchhoff's law, right. So, first one is Kirchhoff's current law and second one is Kirchhoff voltage law. So, Kirchhoff's current law, see, so first law which states that summation of all the charges or all the current getting at the junction has to be 0. So, as here we are talking about capacitor, so we will talk in terms of charge. What I can say that the charge flowing through this one and this one, their summation has to be 0. So, one way I can write sigma qi, where I is equal to 1 to n. In this case we have taken 3 branches forming a junction. So, at junction the summation of charge has to be 0. This way I can say. Another way I can say whatever gets to the junction, same must be given by the junction. So, if I assume that Q1 charge is coming this way and Q2 charge coming this way to the junction, then charge coming to the junction must be equal to charge leaving the junction, because junction cannot store charge. So, here at this junction there should not be any accumulation of charge. So, as there is no accumulation of charge, whatever is coming that must be leaving the junction. So, I can also write it this way, what comes in that goes out. So, what comes in Q1 plus Q2 must be equal to what goes out, that is Q3. So, depending on the way I have considered the direction and all, I can write in the way I have written it in the previous expression, or we can write it this way, whatever comes in that goes out. This law, first law, is basically the law of conservation of charge. If you read the statement written here, the law states that the total current entering a circuit junction is exactly equal to the total current leaving the same junction, right. So, as we are talking about the capacitor, there will be flow of charge. I can tell this in terms of charge, and this is the law of conservation of charge, because charge remains conserved as there is no accumulation, what comes in that goes out, right. So, this way most frequently we will be writing it. So, conservation of charge, that was first law, Kirchhoff's first law, right. Now, second law, if I take a closed circuit this way, this is representing switch, and if I close switch, so what happens, we have seen that the battery delivers charge and charge flows through the circuit and gets back to negative terminal of the battery. So, this is our circuit, right. So, according to this law, as you can read, the voltage law states that for a closed loop in series path, the algebraic sum of the voltage drop around closed loop is equal to 0. Now, what does that mean? If I start from this point and following this path, I get back to the same point, the summation of voltage drop across all the element, if I do for loop, that has to be 0. So, if I say let this be V, this be V1, voltage drop coming here, that is, or let us call it V1, this is V2, voltage drop across this circuit element is say V3, and voltage drop across this circuit element is V4. So, according to this law, V1 plus V2 plus V3 plus V4 is equal to 0. That I can also write summation of voltage, I can also write it this way, del summation sigma V is equal to 0, sigma I is equal to 1 to n depending on the number of elements. So, I can directly say that while moving in a closed loop, if I start adding all the voltage algebraically, then the sum has to be 0. This is voltage law, and there is nothing new in this one. If you say, look at this one, if I name this as A, right, this junction as A, this as B, and this one is C, this one is D, and here it is E, right. When these two are connected, this switch is closed, these two are connected, that will be at same potential, and in the last class we have seen the two terminals at the same potential can be named same. So, there I can write A, right. So, here instead of writing E, I can write A because that A and E both will be at same potential, right. So, this whole thing I can write A. Now, if I start moving across the loop and start writing the potential difference across all the element, look at what we are writing for V1, VA and this is VB. So, this potential difference is VA minus VB, right, VA minus VB. The next one plus VB minus VC, then next one VC minus VD, VC minus VD, and then the last one if you see, this is VD minus VA plus VD minus VA. Now, what this value would be? If you look closely, then this VB and this VB gets cancelled out. This VC gets cancelled out, VD will get cancelled out, and leftover VA gets cancelled out with first VA, and what you are getting is 0, right. So, nothing new. If you move across a loop, summation of voltage drop across all the element in a loop has to be 0, right. Now, this is the law of conservation of energy. What is the law of conservation of energy? Look at this one. Charge, if you take a charge and move across the loop where your starting and ending point is same, then you will write work done is equal to charge into potential difference. If your starting and ending point is same, then the potential difference between starting and ending point has to be 0, and this quantity will be 0, this quantity is 0, right. So, that is why this is the law of conservation of energy. So, first law was the conservation of charge. Charge cannot be stored at the junction, whatever comes in that goes out. And second law, which is the law of conservation of energy, which says that if your starting and ending point is same and you are moving across the loop, then summation of, that is algebraic sum, then the summation of voltage drop across all the element has to be 0. So, this is what we have. So, like in mechanics, any mechanics problem can be solved with the help of Newton's laws, Newton's basic laws. Similarly, in circuit, any circuit problem can be solved by these basic laws. So, what we did there to solve, or what we did in mechanics to solve any mechanics problem, same thing we are doing here to solve any circuit problem. There we apply Newton's law, here in case of circuit we will be applying Kirchhoff's law. So, no matter whatever circuit element is connected, whether it is capacitor, resistor or inductor, we have to apply Kirchhoff's law to solve the circuit, right. Look at the previous one, we wrote it this way. So, first law, which is net sum or summation of charge at the junction is 0, or I can say whatever comes in that goes out. This can also be written this way. If I assume that potential here is some V naught and the potential at this junction is V1, right, and potential of this terminal, that is V2, and here potential is V3. And let the capacitance of this one is C1, C2 and this C3. So, one way of writing is what comes in goes out, or I can also write it this way. See, Q1 I can write Q1, this will be positively charged plate, this will be negatively charged plate. I am writing V1 minus V naught divided by Q is equal to CV, right. So, Q is equal to CV. If I write Q is equal to CV, so I need to multiply potential difference to the capacitance C1 plus the second term. Second term similarly I can write V2 minus V naught into C2, its capacitance, this potential difference into capacitance, plus the last one, or equal to, here we have equal to and then Q3. Charge flows this way. So, charge flows from higher potential to lower potential, that means V naught minus V3 into C3. So, the same expression I can also write this way. So, as you can see that when we are interested in finding charge, I can use first equation, and sometime we will be interested in finding the voltage of the junctions, then I can write the same equation in this format, right. So, depending on requirement I can use this, or I can use modified form of that. So, generally for nodal analysis we will be using this equation. What is nodal analysis, what is loop analysis, that we will see later. But for time being, these two laws are clear. Kirchhoff's law, first law is summation of charge at the junction is 0, and the second law, which is the voltage drop or summation of voltage drop across closed loop, has to be 0. So, these are the two things we have to apply while solving any circuit. So, irrespective of the topic we are going to take in future, wherever we get the circuit, we have to apply Kirchhoff's law. Now, let us see one point. Now, look at this circuit element, which is cell. While moving in a loop, I can cross this circuit element this way. I can move from this point to this point this way, or I can move from this point to this point. So, if I call it A, I call it B, and this one A, B. In first case, I am crossing, while moving in a loop, I am crossing this element this way. I am moving from positive plate to negative plate. While in second case, I might be crossing this element this way, right. So, sign convention we have to decide which one we will take with positive sign and which one we are going to take with negative sign. For that, if the potential difference here is V, as you can see, VA minus VB, when you are going to write VA minus VB, if you want to write, then okay, I will write it here, VA minus VB when you want to write, and in this situation, as I am going from A to B, I am writing VA minus VB, right. as A is connected to positive terminal of the plate, obviously potential at A will be higher than potential at B. That means this quantity should be written plus V, right. A is connected to positive plate of the cell, its potential will be higher as compared to the negative plate, right. So, VA minus VB will be positive plus. So, VA minus VB should be written with positive sign. Now, if you look at this situation, I am moving this way. So, as I am moving this way, I will write first B, VB minus VA, VB minus VA. Look at this one, VB minus VA. B is connected to negative terminal of the cell, right, and A is connected to positive terminal of the cell. So, VA minus VB, this quantity has to be negative. So, it must be written this way, minus V, and obviously if VA minus VB is plus V, if you reverse this one, then here minus sign will come, simple logic, right. So, from here what I can say, while moving across element in a loop, increment from B to A, when you are coming from B to A, B to A, that must be taken with negative sign, while decrement must be taken with positive sign. Look at this one, from A you are going to B, potential is getting decreased, from higher potential you are going to lower potential. So, decrement is taken with positive sign and increment is taken with negative sign, right. I will write it here, increment is taken with negative sign, while decrement is with increment is taken with negative sign, while decrement is taken with positive sign, right. This you have to keep in mind. This is for cell. So, in this chapter we will be frequently dealing cells and capacitor. Let us see what happens when we have capacitor as circuit element. So, if I take circuit element as capacitor and say this is positively charged plate and this one is negatively charged plate, right. Now, there are again two ways, A, B. I may move this way while following the loop. I may cross capacitor either this way or I may cross capacitor this way. So, I may cross capacitor this way, that means I am moving from positive plate to negative plate, or I may be crossing capacitor this way, that means I am moving from negative plate to positive plate, right. In this situation, if I want to write VA minus VB, as we know Q is equal to CV, Q is equal to CV, that means potential difference is charge by capacitance. So, whatever charge that will be here, charge on capacitor, that is charge on the positive plate, divide by capacitance. As this is decrement from higher potential you are going to lower potential, as this is decrement, it must be taken with positive sign. I hope you are understanding what I am saying. Look at this situation. If you are moving this way, VB minus VC, VB minus VA, VB minus VA, potential difference magnitude is charge by capacitance, charge by capacitance, as this is increment, it is taken with negative sign. So obviously if VA minus VB is plus Q by C, then VB minus VA has to be minus Q by C, same situation. Only thing we are writing A first, then we are writing B in first expression, while we are writing B first and A second in second equation. So if I reverse this one, here minus sign will appear, that means this is correct, right. So what you have to keep in mind for not to get confused: increment with negative sign, decrement with positive sign. What all circuit element you are going to get, for all circuit element we will follow this rule. So instead of just seeing this way, we will keep only this thing in mind, and directly we will take plus sign and minus sign based on increment or decrement, right. Increment, again increment with negative sign and decrement with positive sign. So you might be getting confused what I am talking about. Let us take one example so that this whole thing gets clear. This is very important thing, because most of the students commit mistake here while taking sign when they are moving across the loop, right. So I will take some problem, I will solve it here so that you will come to know how to apply this concept while solving circuit. Let us see. So let us just discuss one more point, then we will come to see the circuits. So two capacitors connected, and I want to know how the voltage is getting divided. So if I say the source of potential V is connected this way, how the voltage is going to get divided if this is having capacitance C1 and this one is having capacitance C2, okay, because this also we will be using in circuit. So I already told you that you have to apply Kirchhoff's law for all the situations, right. But here what we are going to do, we will apply Kirchhoff's law and we will get these ready-made result that will help us to solve circuit fast, right. So that is why I am telling you two more basic point. Instead of everywhere you apply Kirchhoff's law, let us apply Kirchhoff's law for these two situations and just remember the result, so that our solving of circuit will become fast, right. So V volt battery connected across two capacitor which are connected in series, then how the voltage is going to get divided. So I can directly say that both are going to have same charge as they are connected in series. So formula is Q is equal to CV, right. If this quantity is same for both the capacitor, same for both the capacitor, that means voltage drop is inversely proportional to capacitance. So voltage drop is inversely proportional to capacitance, that means for first capacitor voltage drop, if I assume V1 and second capacitor if I assume V2, then I can directly write, because it is inversely proportional, then I can directly write V1 is equal to C2V divided by C1 plus C2. Similarly, I can write V2 is equal to C1V divided by C1 plus C2. You can see that voltage drop is inversely proportional to capacitance. By simple logic I can tell, or those who are not understanding logic, they can apply Kirchhoff's law, right. This logic I think clear. Now I am applying Kirchhoff's law to prove what I wrote here is correct, right. So, V volt battery connected to two capacitor which are in series, capacitance, equivalent capacitance, two are connected in series. So, equivalent capacitance C1 C2 divided by C1 plus C2, right. Q is equal to CV. How much charge battery delivers, that charge Q is equal to C equivalent V, right. If this capacitor carries Q charge, then how much would be the voltage drop? Voltage drop. Now focus on this one. Q is equal to CV again. Q is equal to CV. C1, charge on both the capacitors are same. That charge first we have calculated by just reducing the circuit, as these two are connected in series combination. Equivalent capacitance across these two terminal is C1 C2 upon C1 plus C2, right. Now I want to find out value of V1. So, V1 is equal to Q divided by C1. V1 is equal to Q divided by C1. That Q what I have calculated here, I can substitute in the equation. So, I am going to substitute this charge here. If I substitute this charge here, this C1 and this C1 will get cancelled out, and you can see what we are getting. We are getting C2V upon C1 plus C2. Similarly, Q is equal to C2V2, both are carrying same charge. That means V2 I can write, if you substitute here V2, then this C2 and this C2 by Q by C2. So, this C2 and this C2 will get cancelled out, and you are going to get C1V upon C1 plus C2, right. So, I told you the expression by logic, or I can apply Kirchhoff's law, and by that I am going to get same result, right. So, here you can see what is happening. We are dividing voltage V into two parts. One is this one, another is this one, right. So, separately I will write. So, we are going to get V1 as C2V upon C1 plus C2, and V2 is equal to C1V divided by C1 plus C2. This is the voltage division when two capacitors are connected in series. Now, let us see charge division. So, second circuit, charge division. Assume that Q charge comes into parallel combination of capacitors C1 and C2. So, this is C1, this is C2, right. Same logic I can put here, because both are connected in parallel combination, they will have same capacitance. Q is equal to CV. Previous case they were carrying same charge, voltage was getting divided. In this case, as they are connected in parallel, voltage will be same, charge will get divided into two parts. So, let Q1 goes here and Q2 goes here. Q is equal to CV. Here V is same, If V is same, that means charge appearing on capacitor is directly proportional to capacitance. I can say Q1 will be equal to C1Q divided by C1 plus C2, and I can say Q2 is equal to C2Q divided by C1 plus C2. Charge is proportional to capacitance. So, this is by logic. or you can apply Kirchhoff's law. See, so second method, by applying Kirchhoff's law. Voltage here and voltage here must be same because they are connected in parallel. So one equation I can write, Q1 divided by C1 must be equal to Q2 divided by C2, this first equation, right. By instead of writing Q1 by C1, this side if you take term minus Q2 by C2 is equal to 0, that is nothing but Kirchhoff's law. So instead of writing that, I am writing this Q2 by C2 this side, right. And another equation I have is Q is equal to Q1 plus Q2. So these two equations you can solve and you can find out the value of Q1 and Q2. So simplify these two equations, you will get the value of Q1 and Q2. This is using Kirchhoff's law, there we use direct logic. So you can solve this equation and finally you are going to get, I am directly writing. I hope this procedure is clear for two capacitors connected in parallel, how charge is getting divided, right. So we are talking about charge division. So Q1 we are getting C1 Q divided by C1 plus C2 and we are getting Q2 is equal to C2 Q divided by C1 plus C2, right. Voltage division, this is the way voltage will be divided. Only thing you have to keep in mind, it is inversely proportional to capacitance. When it comes to charge division, when two capacitors are connected in parallel, then charge will get divided according to the capacitance, directly proportional to the capacitance. So now we have discussed charge division and voltage division. So if circuit is very simple, we will be directly applying charge division, voltage division, and we will solve the problem. If circuit is little more complicated means there will be so many batteries and it is difficult to reduce the circuit. In all such type of cases, what we can do, we can apply Kirchhoff's law. So we will start from Kirchhoff's law. For simple circuit, I can use these concept and straight away I can solve circuit, right. Now let us take up numerical so that you will understand what I was saying. So see this circuit where this whole arrangement is connected to 12 volt battery and you are asked to find out charge on capacitor, potential difference across the capacitor or potential difference across any 2 point. Any of these questions can be asked related to the circuit. So to solve circuit, the first requirement here is charge. If I know charge at each and every capacitor, then I can answer the potential difference across any two terminal in the circuit. So our requirement is getting charge on every capacitor, right. To get charge on every capacitor, I can apply Kirchhoff's law. So procedure is, assume that charge given by battery is Q, that plus Q comes on the inner surface and minus Q comes on this one, it delivers charge Q. So minus Q is because it gives whatever it gets. Here let some Q dash follows this path, right. Out of this charge Q which is reaching the junction, Q dash goes through this path. The remaining, because charge has to be conserved, Kirchhoff's first law, as charge has to be conserved, the remaining one, that is Q double dash, will be equal to Q minus Q dash. So while solving circuit, I won't be doing this again and again, right. here Q comes, Q dash goes, remaining I will directly write, so that there will be less number of variable appearing on the diagram. So, this much charge flows through this branch. I will directly write this over there. So, charge coming to this one is, this is Q minus Q dash, whatever comes in that goes Q minus Q dash. And look at this one, as these two are connected in series, this charge has to be Q dash, this will be Q dash, and when this reaches here this will be Q dash. This and this, when you add, this Q dash and minus Q dash is cancel out, and through this branch you are going to get Q. Now we have a complete circuit. How many unknowns are there? You can see that we do not know value of Q and we do not know value of Q dash. So, there are two unknowns. So, first step after distributing charge, you find how many unknowns are there. According to number of unknown, you can make equation, because in the case of circuit you can make more number of equation which is larger than the equation required. So, here if I ask how many equation you can make, as you can see we have got one loop here, first equation, one loop here, second equation, and then I can see this bigger loop, I can make 3 equation, but I do not have to write all 3 equation because our requirement is only 2 equations, right. So, any 2 equation will do, any 2 equation whatever you like, you can take this loop and you can take this loop, or you can take this loop, you can take this loop, any 2 loop you select to write Kirchhoff's law. Now, so I will select say this loop and this loop. So, I am starting from this point for this loop and I need to get back to this point. Similarly, here I will start from this point, following the loop I will come back to the same point. So, this is loop number 1, this is loop number 2. As I already told you, you are free to make any 2 equations, right, by any 2 loop of your choice. So, say we are going by this loop, first equation what I can write is minus 12, right, increment. So, when I go from this to this, I can see that I am moving from negative plate to positive plate. As potential is getting increased from negative to positive, it must be taken with negative sign, that is why I have written minus 12 plus. Now comes this element, I have to go like this. So, now comes this element, as charge is given to this plate will be positive, this will be negative, and you are moving from positive to negative, you are moving from positive to negative, potential is decreasing from higher potential to lower potential you are going, then potential is decreasing. I can write for capacitor potential is Q is equal to CV, V is equal to Q by C. So, charge I have assumed on this capacitor Q and by C, C is 6, so I will write 6 here, right, and then comes next one. So, charge here is plus Q minus Q dash divided by 4 is equal to 0, right. So, in this loop there were 3 elements. For first element for battery I have written this term, second element I have written this term, third element I have written this term, then I reached here. There is no element in this branch, there is no fourth term, only 3 element, 3 term came and first equation over, right. You can further simplify, multiply this whole quantity to 24, this will become 12 into 24, and if you are multiplying this to 24, I can see 4q here, and then I can see 6q minus q dash, right. So 10q, final equation will be 10q minus 6q dash is equal to 24 into 12. So this is our first equation after simplification. Second equation, take this loop. Now I am starting from this point and I am getting back to the same point following the loop. So as charge q minus q dash flows this way, this will be positively charged plate and this will be negatively charged plate. This upper one is positively charged because charge is going like this, and this lower one will be negatively charged plate. As you are going in clockwise direction, you are moving this way, and here, then again you will come back. So as you are going in this direction, you are moving from negative plate to positive plate. Negative plate to positive plate, potential is increasing, increment is taken with negative sign. So what I write? Minus charge on capacitor is q minus q dash divided by capacitance 4, this element over, be careful, right. Here you are moving from negative plate to positive plate, potential is increasing, increment is taken with negative sign, that is why this negative is placed. Now as I pass through this capacitor, here charge is given to this plate, this will be positively charged plate, right, and this will be negatively charged plate, charge will be inside, there is less space, that is why I am drawing it outside, actually these charges are inside, right. So charges are inside and I am moving from positive towards negative. So positive higher potential to lower potential decrement. Decrement is taken with positive sign. So what I write? Plus q dash divided by 3. So this branch, this element over, this element over, this element. Again this will be having positive and this will be having negative, and you are going this way. That means from positive to negative, positive to negative, decrement. Decrement is taken with positive sign. So plus, so next term is q dash divided by 6 is equal to 0. Right. Now I can simplify this one. So if I multiply this whole thing by 24, then this will become 6, right. So minus 6 q minus q dash plus 8 q dash and plus 4 q dash is equal to 0. So this will make it plus q dash, right. So here I can see 12 q dash, here I can see 6 q dash, 12, 6, 18. So this will give me 18 q dash, and then minus 6 will come on other side, that will be equal to 6 q. So from this equation I have q is equal to 3 q dash, q is equal to 3 q dash, q is equal to 3 q dash. If I substitute in this equation, q is equal to 3 q dash, q is equal to 3 q dash. If I substitute in this equation and simplify, here 3 q dash will appear, or q is equal to 3 q dash, here 30 q dash I can see, 30 minus 6 will give you 24, that 24 will get cancelled out, then q dash we are getting 12, right. So this q dash we are getting 12 microcoulomb, right. Now if you have this q dash, what is the potential difference across this capacitor? Look at this capacitor, formula is q is equal to Cv. Q is equal to CV, right. Capacitance, I need to find out potential difference across this. That means potential difference, this V is equal to Q by C, and Q I got 12 and divided by its capacitance. Capacitance I am getting 6, that means I am getting 2 volt, right. So, this is the procedure to solve the circuit. Distribute charge, first step distribute charge. Here at junction I use first law, right. So, using first law you can distribute charge. Keep in mind, whatever battery gives, it must receive the same. If you have committed mistake somewhere here, this quantity won't be same as this quantity. So, if this quantity is coming this same as this quantity, that means division you have done properly. Now, after division, count number of unknown. So, we got 2 unknown, we require 2 equation. So, in this case I can make 3 equation, but I require only 2 equation, that is why I am making 2 equation selecting any 2 loop, right. So, first loop I selected, I made the equation, and second loop I selected, I made the equation, and I simplify, I got answer, right. This is the way you have to apply Kirchhoff's law. Now, as our circuit you can see, as the circuit is simple, I can reduce the whole circuit by simple technique of voltage division, charge division. See, so I will redraw the circuit again, and or here itself I can tell. I hope this procedure is clear. I will solve the circuit here itself. Now, look at this one. These two are connected in these two I am talking about. These two are connected in series, right. 3 and 6 are connected in series. 3 into 6 upon 3 plus 6 will give you 2. 3 into 6 upon 3 plus 6 will give you 2, right. That means the equivalent capacitance of this particular branch, let us call it C equivalent, is coming 2. If this is 2, then that 2 and this 4, they are connected in parallel. So, this equivalent we got as 2, I am writing it here, and then I am connecting 4 this 2 and 4, they are connected in parallel. So, parallel combination formula I can apply, C1 plus C2. So, 2 plus 4 will give you 6, right. So, this whole thing is nothing but 6. So, I will draw 6 microfarad here. Now, by seeing only I can tell all these values. This is 12, 6 and 6. As these two capacitors are same connected in series, voltage will get equally divided. As voltage will get equally divided, I can directly write 6 volt here. This voltage will be 6 volt and this voltage will be 6 volt. The supply is 12 and voltage are getting equally divided. 12 divided by 2 will give you 6. If this is 6, then charge appearing over here on this capacitor, how much charge will appear, right. So, Q is equal to CV, CV, that means CV, Q is equal to CV. I am talking about charge. So, capacitance I have, voltage I have, directly I can write 30 6 microcoulomb. So here this charge will be this will be 36 microcoulomb. Now look at this circuit. So that means battery is giving 36 microcoulomb. Here this is 36 microcoulomb, and then there are two ways available for charge to flow. There are two ways available for charge to flow. Charge will get divided, and we have seen charge gets divided proportional to the capacitance. Capacitance of this one is 2 and capacitance of this one is 4. Here I divided voltage. Fortunately we got capacitance same, half directly I have written. Now here this part, this branch, you see this branch is having capacitance 2 and this is having 4, and we know that charge after division will be proportional to this capacitance. So what coming is 36, and that will be proportional to the capacitance. This side it is 2 divided by 2 plus 4, this is 2 plus 4. So I can see 6 here, 6 and 36, this will give you 6, and here I am getting 6 microcoulomb. So this is say Q1. So Q1 flowing through this branch is 6 microcoulomb, and charge flowing through this branch, that is 36 into this much charge is coming, and that is getting divided into 4 proportional to capacitance into 4 divided by 4 plus 2. So this again 36 and 6 will give you 6, and this is coming 24 microcoulomb. So charge flowing through this branch, that means this will be the charge here and this is charge here. Now once you have charge, you can find out capacitance, right? Q is equal to CV. Sorry, once you have charge, you can find out the potential difference, right? Q is equal to CV. So across any point, if I ask, for example, if I ask CB, what is the potential difference across CB? VCB, CB. So you can locate VCB here. This 4 and this 2 was 6. So this is nothing but this 2 and this 4. As you can see, the voltage drop across these two terminals is 6 volt. You can directly predict this voltage will be equal to this voltage, and voltage across here is 6 volt. So here you can see I am not applying Kirchhoff's law because I have the ready-made formula what I have derived using the Kirchhoff's law. As circuit is simple, I can use voltage division and charge division and directly get the answer. But sometimes it is difficult to divide charge or divide potential, especially when we have multiple sources. Here we had only one source and circuit was simple. Either you can solve this problem by Kirchhoff's law or you can solve this problem by voltage division, charge division, right. So if circuit become little more complicated, say we have one more source. So let us take one more source. See, in this case we have got two sources and 3 capacitors which are neither in series nor in parallel. They are neither in series nor in parallel, so you cannot reduce the circuit. As you cannot reduce the circuit, the only option left is directly apply Kirchhoff's law. You cannot divide voltage or you cannot divide charge directly, right. So while solving such type of circuit, as we are not aware which battery accepts charge or which battery delivers charge, you can assume any direction of flow of charge. If you have assumed wrong direction, then automatically with minus sign you will get that particular value. So, I do not know whether charge is flowing this way or charge is flowing this way here. Similarly, I do not know whether charge is flowing this way or this way, right. So, I will assume some direction and I start solving it. Now, if I assume this way charge is flowing, Q1 on this capacitor charge appear as Q1 and here it will be minus and then this is Q2 and out of this Q1, say this is Q2 and the remaining charge, that is Q1 minus Q2. So, this Q3 I am writing, this Q3 is nothing but, this Q3 is nothing but Q1 minus Q2, right. So, I have no idea in what direction charge flows. I assume some direction, I start with some assumption that say this delivers Q1 charge and that gets divided here and this plate receives Q2 charge, this gives away Q2 charge and then here this Q2 charge enters into positive terminal of battery and this gives Q2 charge. So, later we will talk about charging and discharging of battery. So, positive terminal of battery, when it is getting discharged, charge flows out. When it is getting charged, then charge comes in, right. So, charge may flow out or may comes in depending on whether we have charging or discharging. Obviously, in this situation you can see that this is 20 volt battery and this is 10 volt battery. Obviously, finally, this will be in this direction, right. So, but we have assumed some direction and if directions are not correct, that particular quantity will come with negative sign, right. So, number of unknown if I count, then I do not know value of Q1 and Q2 because Q3 is in the form of Q1 and Q2 only. So, basically there are two unknowns. So, if I start from this point for this particular loop, I require two equation, I will be taking two loops. You can move clockwise or anti-clockwise, right, it does not make any difference. Similarly, here I will start from this point and then I will get back to the same point. So, while moving through loop, I will get back to the same point. Similarly, while moving through the loop, I will get back to the same point. Now, let us start writing. So, for loop number 1, you are starting from this point and moving through this loop, you can see 3 elements, right, you can see 3 elements. So, let us write for this element first. So, for this element I can write as I am moving from positive plate to negative plate, decrement is taken with positive sign. So, Q1 divided by 2 with plus sign because this is decrement plus, look at this one, here it receives this much charge, that means this will be positive and this will be negative, right, and as you are moving this way, decrement, right, decrement is taken with positive sign. So, I write Q1 minus Q2 divided by 6 plus increment minus 10, right. Now we can simplify. So, if I multiply whole equation by 3, by 6, then here I will get 3q1 plus, as we are multiplying with 6, here I am getting q1 minus q2 is equal to, get 10 on the other side, and as we have multiplied by 6, it will become 60, right. So, 4q1 minus q2 is equal to 60. 4q1 minus q2, 4q1 minus q2 is equal to 60. This is first equation. Now, second equation. See, we are starting from this point and moving this way. So, when you are moving this way, you are moving upward direction for or through this capacitor, where you are moving from negative plate to positive plate, negative to positive, increment is taken with negative sign. So, I will write minus, I will write minus increment, right. So, q1 minus q2 divide by 6, this over increment with negative sign over, then as charge is flowing this way, this will be positive and this will be negative. You are moving from higher potential to lower potential, decrement, that is plus q2 divided by 4 plus. Now, come to this one, again there is decrement, plus 20. This you can simplify, again you can multiply by, say, 24 if you are multiplying, then this will become minus 4 q1 minus q2 plus 6 q2, and this on other side if I send into 24, right. Let us simplify, this is coming minus 4 q1 and then this plus q2, right, plus q2, 4 q2 plus 6 q2, this will make it 10 q2, right. I will write 10 here. Q2 is equal to minus 20 into 24, right. Now, this is our second equation. If I add these two, here I can see minus 4 q1 and here I can see plus 4 q1. So, if I add these two, then this and this will get cancelled out, and here you are going to get 9 q2. So, this equation will be 9 q2 and this is 480 minus 480 and this plus 60, that will be 420 minus 420. So, q2 what we are getting minus, if you simplify, then it will become by 3 if I divide, then this will be 1 and 4, 140 by 3 we are getting microcoulomb, because all the capacitor given in microfarad. So, minus 140 by 3 microcoulomb. Here this minus sign indicate that whatever direction we have selected, opposite to that charge will flow. So, this instead of flowing this way, Q2 flowing this way, what we have selected, charge will flow this way, right. So, direction of the charge flow will be opposite. Now, you have the value of Q2, Q2 you can substitute here, you can find out the value of Q1. You have the value of Q1 and Q2, substitute value of Q1, Q2 here, you will get Q3, right. So, I hope now you understood. Previous case circuit was simple. As circuit was simple, I directly apply voltage division, charge division, and I simplify the circuit. In this case, circuit was little complicated. I can solve problem by applying Kirchhoff's law. While applying Kirchhoff's law, you have to be very careful with signs what we are putting in front of expressions. Increment is taken with negative sign and decrement is taken with positive sign, right. So, I hope this example is clear and previous one is also clear. Now, let us talk about the energy stored in the capacitor and the losses happens during reconnection. So, here I have selected very simple problem. A capacitor was first connected to source. So, obviously when it is connected to source, if this is V and its capacitance is C, then this will have charge Q is equal to CV. Directly I can write Q is equal to CV. Now, question says that capacitor is disconnected and connected to the battery with reverse polarity, right. So, same capacitor is first disconnected and connected with reverse polarity. So, battery as it is, and I will draw the circuit again, right, and this side I have, because I have reconnected it with reverse polarity, minus sign, and this is having plus sign, right, and then I am going to close the switch. So, after charging capacitor, we disconnected capacitor and we are going to connect it with reverse polarity. Question is how much heat generated. Similarly, I can ask how much work is being done, right, what is the change in potential energy, all these questions I can ask, right. So, this is having, look at this charge, this is minus CV and this is having plus CV charge. So, you can see that once you connect it again with reverse polarity, earlier potential here was V and potential here was V, with this terminal at higher potential and here this terminal higher potential. Now, when you reverse it, here this terminal is at higher potential and in this branch this will be at higher potential. So, obviously you have disturbed the equilibrium, right. Here in a steady state or equilibrium it had this static charge CV and suddenly you reverse the polarity, then obviously you are going to disturb the equilibrium. Once the equilibrium is disturbed, battery will give additional charge to get to the new equilibrium or new steady condition. So, when I close this one, immediately some charge will be delivered by cell, I do not know how much, right. So, let us call it, here I am writing this as Q, let us call it Q dash, I do not know how much, right. So, this charge will appear here, assume this charge is greater than minus CV, this is just assumption, right. So, if this charge reaches here, then charge on this terminal will become Q dash minus CV. As I am assuming this to be greater than this one, this will become plus, right. And similarly, battery must receive the same charge, Q dash will flow out, right. So, Q dash flows out, I can write the second term, this term as as Q dash flows out, right. So, minus Q dash plus CV, I will take minus out, this can be written this way, but this is same as this minus, when goes inside it will make it plus, right. If Q dash is greater than CV, then the charge we are drawing here, this will be negative. So, for new equilibrium, this will be the situation, right. How many unknowns? We do not know value of Q dash, right. How much extra charge flows through battery, how much extra charge flows through battery to get to new equilibrium, right. So, this charge keeps flowing till the potential here and the potential here becomes same with this terminal at higher potential, as this terminal is also at higher potential. So, from here I can write, see, if I apply Kirchhoff's law going this way, right, going this way, I will start from this point and again get back to the same point. I can see increment in the potential, negative plate to positive plate minus V. Then I can see decrement, decrement is taken with positive sign, so I will write plus. Charge on capacitor is the charge on positive plate, that is Q dash minus CV divided by capacitance C is equal to 0. Now I can simplify, this CV and this CV will make it 2 CV. So, Q dash what we are getting is equal to 2 CV. That means battery will deliver 2 CV charge. If I put 2 CV here, if I substitute in place of Q dash, I substitute 2 CV, then you can see what we are getting on capacitors. Finally, so if I substitute this value here, 2 CV minus CV will give you CV, so this will be CV plus CV, and here similarly minus CV will come. Right. So, battery delivers, after reconnection battery delivers extra charge 2 CV, so that the potential here and potential here become same, right. Now, if I ask how much work battery is doing, I hope this part is clear. So, I will erase this part. What I have done, capacitor was initially having charge, I just close the switch, charge flows. Using Kirchhoff's law, I came to know how much extra charge will flow. That extra charge we got 2 CV, right. Now, if I ask what is the work done by cell, work done by cell, how much charge, extra charge battery gives 2 CV. I am interested in work done by cell after reconnection. This is after reconnection, after reconnection, right. So, charge given by cell is 2 CV, through potential difference V, I multiply this to V, right. So, we are getting 2 CV square is the work done by cell. If I ask how much is the change in potential energy or change in the energy stored in capacitor. So, earlier charge was CV, now also charge is CV. So, initial energy stored is half q square by c, half q square by c, and final energy stored is again, because charge is same, that is half q square by c. So, both the terms are coming same, that means change final minus initial is 0. Battery is doing work, but there is no change in energy stored in capacitor. As there is no change in energy stored in capacitor, the whole work will go in the form of heat, because we have seen that work done by cell is equal to change in energy stored plus heat generated. Change in energy stored is 0. So, here I will write 0 and work done by cell is 2 CV square. That means this much amount of heat will be generated after reconnection, right. Whole work done by cell will completely go in the form of heat. If you remember, when we talk about the heat and the work done by cell, there for the simple case, there we got half of the work done by the cell goes in the form of change in energy stored in capacitor, and the remaining half gets converted into heat. But here we are getting totally different result. That means energy getting converted into heat may be any factor of the work done by cell. It might be half, it might be 0, or it might be a complete work that is done by cell. So, in this situation, the whole energy is getting converted, or whole work done by cell is getting converted into heat, right. So, this is it for today's session. In our next class, we will take few more such example, so that you will get complete conceptual clarity. So, I hope you enjoyed today's class. Thanks for watching.